Good afternoon. So today we are starting Unit 4. Unit 4 and 5 are two big units. In Unit 4, we have our big bridge project that will come right after spring break. So what it's about is Unit 4 is all about design. So how we design products, the thought that goes into designing products, the process that we have to go through in order to get these products. So if you're in Haiku, you notice you have Unit 4 available to you now. You see we're not doing too much today with it. We're just going through a set of notes that you actually do have to turn in on Haiku, and then you'll be finishing with your midterm. And I'll go over that at the end of the Edpuzzle. So you're starting, go ahead and open up Principles and Elements of Design PowerPoint notes. Notice you do have to turn these in at the end, so I want to make sure that you are filling them out as you go. You'll have a mini project starting on Monday with these, so it's very important that you have this set of PowerPoint notes completed. But that's it, just the PowerPoint notes completed and turned in. That's your grade for that. So open them up and we will get started. So it's going through, it's kind of broken into two different sections. First, we're going to talk about design as far as what it takes to design something when you're an engineer, architect, designer, whatnot. And then we're going to look into the aesthetics part of design as far as kind of the artistic, why is a product designed the way that it is. So make sure you have it split screen so you're able to fill in your notes as we're going through the Edpuzzle. There won't be as many questions you'll notice in these Edpuzzles because I want you to focus on filling in those notes, pausing when you need to make sure you have it all complete. So the unit big idea is the engineering design process is a systematic iterative problem-solving method which produces solutions to meet human wants and needs, or wants and desires. So this is the definition of the engineering design process. You'll hear it many, many times throughout this unit. It will get stuck in your brain, hopefully. That's the whole point. And we'll talk about this a little bit more in depth next week when we actually go over the steps of the engineering design. But for today, our lesson big idea is that engineers and designers must incorporate design principles when generating solutions to problems. So we have to look at certain design principles and figure out, have we followed the design principles, and evaluate your products based off of these in order to make those solutions to the problems that we have. All right, so to start with, to solve problems, engineers and architects must know many different things, but specifically, we want to make sure that they know scientific knowledge and mathematical applications. So again, remember, STEM is science, technology, engineering, math. We're all interrelated. So as an engineer, not only do we have to know technology, but we also have to be aware of and have previous knowledge in science and math. So think back to in Unit 3 when we did the mechanical advantage and Ohm's law. We just touched on two very simple scientific principles. There's many more out there, but we had to have that science knowledge and mathematical application because that's what the equations were in order to apply Ohm's law and to create the circuits as an engineer. So design requires taking constraints into account. We've talked a little bit about criteria and constraints, but we are going to fully dive into them this unit. Constraints meaning limitations. So we have to take into limitations of people's physical limitations. Are they tall? Are they short? Are they in a wheelchair? Do they have a cane? Are they physically fit? So you have to make sure you're taking the considerations of everyone. Biological, thinking about the health of somebody. Economic, thinking about money limitations. Political, social, ethical. Remember, we're talking about morals. And what people believe, their beliefs, what they believe in. And then finally, aesthetic. And that's what we're going to kind of focus on second half of these notes today. But those are the looks. How is something designed? Why is it made look the way that it does? All right, so as a designer, you have to have certain personal characteristics to make you successful. You want to make sure that you're creative, have that creativity. We've done many design challenges now, and hopefully by now you've realized that the more creative you are, the better the product is, because not only have you thought outside of the box as far as for your product, but other people haven't thought of that yet. So your product is going to sell over others because you have the brand new idea. However, not only do you want to be creative, you want to be resourceful. So just being creative isn't enough. You have to make sure that you're not being lazy, you're looking things up, you're doing your research, you're being resourceful, reaching out to people, and have that connection. The ability to visualize and think abstractly that goes along with your creativity. And then finally, designers also have to take into account human values and limitations. So that's looking back at those constraints again. Then we have our design principles. So there are 4 design principles when you are looking at a product that you are using to evaluate that product. So all technologies are evaluated using flexibility, balance, function, and proportion. Flexibility can mean 2 different things. It can either be the flexibility of the material itself, so how well is the material designed for the product and the properties of that material, or it can also mean the purpose. So if I have an alarm clock sitting next to my bed, if that alarm clock also plays the radio, now it's multi-purpose, so it has flexibility because it can do more than one function. Balance is the position of elements in relation to each other. So looking at a glue gun, why did they put the trigger down on the bottom? Why isn't it on the top? We just think it's natural because we pick it up and we use it, but somebody had to design it at some point. So if you think about it, if it was on the top, all of a sudden it becomes a 2-handed product. But by putting the trigger where it is, we can just use it with ease in one hand. The function, obviously, we're talking about the purpose of the object, and then proportion, the different size elements in relation to each other. So why is the trigger the size that it is? Why is the glue gun the size that it is? We talked about cell phones. The whole point of a cell phone is it can fit in the palm of your hand. If it was larger, it'd be out of proportion and wouldn't fit in our hand. So these are design principles. Later, we're talking about principles of design, which are different. So you have to make sure that just switching those 2 words around, the clarification. So design principles, there's 4 of them. Then we go over universal design. So this is ideally all products you want to have in one large universal design. So all products and environments, all new environments and products should be usable by everyone regardless of age, ability, and circumstance. So we're saying an ideal product should be able to be used by somebody that's 8 or that's 80. Should be able to be used by somebody that may have to be in a wheelchair or not be in a wheelchair, may be at church or not be at church. So no matter what the circumstance, ability, age, your product should be used by anybody. Now we know this isn't always the case with all products. If you think about different things, a lot of sports equipment is not going to be used by somebody that's 85 years old. But ideally, everybody should be able to use it. That's the goal. And then finally, we have our design considerations. So as you're going throughout your process of designing, you're taking into consideration these different things. First, design is the result of a formal sequential process. So that's our engineering design process that we're following. It's sequential, it goes in order, and you're always following that order. And we'll talk about that next week. Then you have your design problems that seldomly arise in clearly designed form. So far, everything I've given you has been black and white. I give you the problem for the design challenge and you solve it. But that's not usually how it is. Usually you have to figure out the problem yourself. So you might not have clean drinking water. Well, you have to figure out the problem. Why don't I have clean drinking water? Is it because there's rust in the pipes that's getting into it? Is it because my original source of the lake is contaminated? So you have to figure out the problem within the problem. And then design is driven by profit motive and market. That goes back to everything essentially is driven by money. Design requirements sometimes compete with each other. So talking about the competitive nature of companies, but more importantly, talking about trade-offs. So your compromises. Is it better to have a flexibility product that can do multiple functions, or is it better to have a product that is well balanced? And then design is the result of goal-oriented research. That is connecting back to when we talk about research and development. And finally, possibly most importantly, designs must be continually refined, checked, refined, and improved. So I've been going over with you since day one. Nothing is perfect. There's always room for improvement. So no matter what your product is, you might think it's perfect now, but it can always have room for improvement. They continuously come out with new iPhones because there's always room for improvement. All right, so that is design overall, as in any products, what we're trying to do, what engineers are trying to have to take into consideration, and what they're trying to accomplish with their products. Now, the next thing that we're going to start looking at, and make sure again that if you need to, make sure you're pausing, going back to fill in those notes as we go. That is the point of this. We're looking at our principles and elements of design. So this is taking the artistic approach to a product. Why do we have the color? Why are they the colors the way they are? Why is it the shape that it is? The aesthetics of it. Is it purposeful for what? Is it designed purposely for what it should accomplish, for the function of the product? So first, let's just talk about design. What is design? Design is an interactive